Okay, ladies and gentlemen, today I'm only going to be able to get up the second page of the answer key, and I will get the first page up tomorrow. But since we're doing the graphing as our first objective, I thought I would focus on page 2. So we're actually going to start with problem 13, though, and in these directions, you have to write the equation for either the absolute value or the piecewise function. So the first two are absolute values. So going off of the equation that you have for absolute value, assuming everything's addition, the first thing I need to do is establish what the vertex is, and on 13 it is 3, 1. And then the other thing I want to establish is what A is, and A is negative first because it's upside down, and when I try to figure out what the slope is, it's down 3 and over 3, so I can just say negative 1 instead. So when I go to write my equation, it's going to be y equals, you could also use f of x, negative 1, absolute value bars, and then x plus the opposite of my 3. So negative 3 and then plus k, or 1 as is. And there is 13. So same idea for 14. First I'm going to establish the vertex, which is negative 1, negative 1. My a is a positive number because it's a regular v, and my slope is up 2 over 1. So here goes the equation. 2 absolute value bars, x plus the opposite of h, so I'll use 1. And then close my bars and plus negative 1, k as is. So on 15, what I'm going to do is write the absolute value for this piecewise function. And for this piecewise function, what I'm going to do is just on the graph itself, first I'm going to write down what the equations are as lines. So assuming that the one on the left side, the left part of the V, keeps going down at a pattern of down 1 over 2, I'd go down 1 over 2, and I'd have a point right there. So as far as this equation goes, I'm going to erase this now. As far as this equation goes, the line is y vertex of negative 1, so plus negative 1. And then my slope is actually a negative slope because technically it is going downhill. And that slope is up 1 over 2, so negative 1 half x. And then the other one is also going to have a slope of up 1 over 2, so 1 half x. But there I can clearly see what the y coordinate of my line is, excuse me, it's plus 1. So when I go to write the piecewise functions, I can use f of x, I could use any of them. And I'm going to start with the one on the left, negative 1 half x plus negative 1. Then the one on the right, so positive 1 half x plus 1. And then when I go for my domain restrictions, that all happened at x being negative 2. And I'm just going to say x is less than negative 2 and x is greater than negative 2. If you want to make one of them equal to, you are more than welcome to do that, but the picture doesn't really establish that. Those points are just points on the line there and to say if it includes it or not. All right, number 16. Number 16, when I go for the vertex, or I'm sorry, the three piecewise functions, I'm going to start with the horizontal. And if you notice, the scale is at 2. So this isn't y flybys at 2, it's y flybys at 4. And then this line has a slope of up 3 and over 1. And I can do that because the scale is consistent on the x-axis and the y-axis. So for this line, my slope is positive 3x. And then my y-intercept, if I kept up this up 3 over 1, so I'd go up 1, 2, 3, and over 1, that point right there would actually be 10. Okay? And then the other one is almost just a mere reflection of it, except it's y equals negative 3x plus 10. So when I go for my piecewise function, going from left to right, I have 3x plus 10, I have 4 and negative 3x plus 10, and then my boundary lines are at negative 2 and 2, and for the 3x plus 10, it's less than negative 2. My y flies by at 4 is in between negative 2 and 2. And my negative 3x plus 10 is when x is greater than 2. Again, they don't show if it's open or closed circle, so I just didn't bother putting any less than or greater than equal to. Number 17, I've got two lines. So the one on the left is a y-intercept of 0, and the slope is just actually going up. It's just y equals x. And then the second one has a y-intercept of 0, so I don't need to put anything like plus 0, but my slope is up to and over 1, and it is also positive. So when I go for this piecewise function, I'm going to list x first because it's on the left, and then 2x. And then all my boundary restrictions are at 0. So x is less than 0, and x is greater than 0. Whoops. And 18. 18, these are a bunch of y flies by. I have a line at 5, y flies by at 4, at 3, at 2, and at 1. So writing this one's actually going to be pretty simple. I'm going to start with 5 and work my way down. And then as far as my restrictions goes, I'm going to do a little erasing here. For the 5, it goes in between -5 and 4. And here they definitely note what's open and what's closed. So next to the -4, I should underline my less than. From 4, it goes from -4 is in between, I'm sorry, 4 is in between -4 and -3, including -3. And the pattern just keeps going. And that's number 18. All right, number 19, it says write the equation of the line that passes through -2, 6 and it's parallel. So just a quick visual. My original line is 5x minus 8. It's going something like that, pretty steep. And when I'm done, I should have a line that's parallel to this and going through -2, 6. So if that were -2, 6, that's going to look like that. So indirectly, they tell me the slope, because if the slope of 5x minus 8 is 5, and my new line is going to be parallel to it, my new slope is definitely 5. So I can start my answer. And now to figure out what b is, I'm going to take this point, and I'm actually going to use the y equals mx plus b version for this round. So in for y goes 6, m is 5, x is 2. And either, if you use y equals mx plus b or the point slope formula, which I'm writing down right now, you're still going to have two steps. You're going to multiply one and then either add or subtract. So I'm going to multiply. And now to get b by itself, I'm just going to add 10, and then that makes b be worth 16. And I can put that over here. So there is number 19. 20 and 21, we did talk about these in class. Just as a reminder, direct variation, all my lines definitely go through 0, 0. And that means instead of y equals mx plus b, I'm just going to have y equals mx, because b is always going to be at the origin at 0. So when it says the variables x and y vary directly, write an equation that relates x and y. One point is 2, 4, or I'm sorry, -4. And since they say it's direct variation, the other point is 0, 0. So I can still subtract my y's and my x's and get my slope. And now that's all I need. I'm done. Y equals -2x. However, there is a faster way. This is a shortcut. And if I want to find m out, okay, so I had a brief interruption, so if I don't quite pick up right where I left off, forgive me. So a quicker way, instead of subtracting the y's and the x's, since there is no y-intercept, I can simply find m by just taking y and dividing it by x. And that's actually what I'm going to do over here. Instead of using 2 and -3, and that was a typo as I pointed out to you guys, in 0, 0, I'm just going to take my y-coordinate, divide it by my x-coordinate, and I've got m. So now I can write my equation. All right, let's move on to the graphing. So for the graphing, we've got a mixture of piecewise and absolute values. And in the piecewise, we've got lines. So the first thing I'm going to do is graph my domain restriction line. So I've got 1. That's a little thick. And over here I have it at -3. And now I'm going to graph. So first, before I graph anything, I want to make sure they are in the right order. And in the first one, I should actually probably graph the -3x, -x plus 3 line first. Whoops. And then graph the other one second. So that's what I'm going to do. All right, hold on one second. Okay, so, and remember, you can always erase. So starting with the 2x, I'm sorry, the negative x plus 3, here is my y-intercept of 3. And remember, negative slopes go downhill, so don't get confused by that. From there, I'm going to go up 1 and over 1. And I'm actually going to go one more because my boundary line is at 1. So I can now make my straight line with a straight edge, not what I'm doing. And I do want to make this a closed circle. No, I'm sorry, not for that one. I'm looking at the wrong one. I want to make that an open circle. All right, and then going for the 2x plus 3, when I do this one, I'm going to start at 0, but again, I'm not going to really need that point, so I'm just going to mark it and then erase it later. And my slope is up 2 over 1, so I'm overlapping this point. I'm just going to keep up that pattern and then make my line. And here, if you want to like close half the circle, you can. You're more than welcome to. But what I am going to do now is just take my eraser. I don't need this little point right there, so it's gone. And that is number 22. All right, as far as 23 goes, when I take care of 23, which one would I do first? I would graph the first one first, x plus 6, and then I'll go to the second one. So with my boundary line at negative 3, I'm definitely going to just lightly mark my point. So here is my y-intercept of negative of 6, but I don't need it. And remember, this is going to go uphill as a positive slope. Or no, I'm sorry, I don't need it, yep. So down 1 over 1. But it's not until the ones to the left of my yellow line do I actually need. So I'm going to start graphing here. And then luckily I can take my eraser and erase those. And I will need a closed circle. And so this is x plus 6, but I only want x plus 6 when x is less than or equal to negative 3. And then for the second one, I'm going to have a y-intercept of negative 3. And then this is going downhill, so I'm going to go up 2 and over 3 to get that downhill look going. And then down 2 and over 3, and that's enough points I can connect. And this one would be an open circle, and that's number 23. All right, 24, which one should I do first? I should probably do the x minus 1 first, because that's the less than 2, and then I'll graph the negative x. And I'm going to make a line at 2 for my boundary line. And let's go ahead and start. So for the x minus 4, here is my y-intercept of negative 4. Remember, this is going to go uphill, so up 1 over 1. But I don't need any further than that because remember, I'm looking to be left of my yellow line. So a few more points. Can take my straight edge, mark it, and this is a closed circle. And then for the negative x, I am going to start at 0, but I won't need this point, so I will be coming back to erase it. And I'm going to have a negative slope which goes downhill. So down 1 over 1. And you notice it overlaps that 1 point. And where the red point is actually where I need to start. Draw my line. And if you want to make part of it a half circle, you're more than welcome to, but it can all be closed if you want. Okay? And I'm going to go back and just erase some of those points that I don't need. And now I'm going to go on to 25. So 25 is just a line. Now, if you guys really want to rearrange it, you can. My suggestion, if you rearrange it, is I would actually add the 3y to the other side. And then subtract the 24 back over. But remember, if you divide by 3 here, you have to divide everything by 3. And that's where our mistakes might happen. Okay? So that means you would have a slope of 4/3 x and a y-intercept of negative 8. But I'm not going to do that. I'm going to leave that there for a brief second. I'm actually going to use the 0. So if x is 0, what's y? So if x is 0, I'm going to add the opposite real quick. Hold on. If x is 0, I just cover up the 4x, and then I have a little problem to solve for, and y is worth negative 8. So as soon as I know that, I'm going to go to where y is negative 8. Whoops. And I'm going to erase this other stuff now. Don't need it because I want you guys to focus on it. And I was a little off there. And then I'm going to do this again, but this time I'm going to make y be 0. So I'm going to cover it up, and then x is just for 6. So as soon as I know that, I'm going to go immediately to where x is 6. And now I've got my line. Take a straight edge, not what I'm doing. And it should be dashed, so I'm going to fix that in just a second. And now I need to test my point because I'm shading since it's an inequality. And when I test this point, I'm going to put 0, 0 in for x and y, and I end up getting 0 is greater than 24. And that's not true. So that means 0, 0 wouldn't work. Neither would any of these points. So all the points that work are below or kind of to the right of it. Okay? A couple more to go. Number 26, absolute value. So with absolute value, remember that in absolute value, you got a V shape. So the first thing I'm going to go for my vertex, which is 3, 4. And we did talk about why we take the opposite of 3. Because if I put 3 in for this x, it is going to force the absolute value bars to become 0. And that's what we're trying to do. Because getting that to become 0 forces us to find the vertex first. And that's going to be very important, what I just explained to you guys, when you do the advanced portion of the test. So why do we take the opposite? Because it's a shortcut to figuring out what number, if I put it in for x, will make my bars turn into 0. Okay? So anyway, I've got 3, 4. I'm going to go over 3, up 4. Here's my vertex. It's a regular V because my A is a positive 1/3. So I'm going to go up 1 and over 3 to the right and to the left. And maybe do this a couple times just to get an idea of the line. And then you can make your V. Very, very wide. And it's very wide again because A is less than 1. All right, 27 is one of those zeros. I'm not going to rearrange this one. If x is 0, I cover up the x's. Then y becomes worth -7. So I'm immediately going to put a point at -7 on the y-axis. And then I'm going to repeat this, but this time I'm going to make y be 0, so I cover up the y, and x is worth +7. So I'm going to go to the x-axis where it's 7. This one is a solid line. I'm ready to test. So I'm going to test 0, 0, put it in for here, and is this true? Is 0 less than or equal to 35? It is. So that means all of these points over here work. And last one, number 28, another absolute value. So my vertex is 7 because 7 forces the absolute value bars to become 0. And if I add the adk, I'd add 0. So there's my vertex. A is a +6, so it's going to be very steep and a regular V. So I'm going up 6 and over 1 for my V. And now I can make my V. Okay? And there you go. There is the graphing, or I'm sorry, the second page. We'll get the rest of the page for you guys tomorrow.